Have you ever wondered where the concept of zero originated or who first introduced the decimal system? Let's travel back in time to around 1200 BCE to the Indian subcontinent. This is where the dawn of mathematics in India began, and what a bright dawn it was. The Indus Valley Civilization, one of the world's earliest urban civilizations, was already demonstrating the practical application of mathematics. They cleverly used standardized weights, geometric shapes, and precise measurement tools, showing that mathematics was indeed a part of daily life, even back then. But the story of Indian mathematics doesn't end there. As we transition to the Vedic period, we find texts from this era that mention large numbers and partial fractions. One of the most noteworthy contributions from this period is Brahmagupta's identity, a fundamental concept in number theory. Brahmagupta, an Indian mathematician, proposed a numerical formula which states that for any two pairs of integers a, b, c, and d, if a2, b2 equals sine c2, d2, then a plus b asterisk, ab equals sine c plus d asterisk, c, d. This was a significant step that greatly influenced the field of mathematics. Now imagine, more than 3,000 years ago, Indian scholars were already grappling with concepts that we find in our textbooks today. The Sulba Sutras, composed during this period, contain rules for geometric constructions and Pythagorean triples, including an early expression of the Pythagorean theorem. If you've ever wondered about the origins of this theorem, well, it has roots in ancient India. Baudhayana's Sulba Sutra, another significant work from this period, includes examples of Pythagorean triples and the general Pythagorean theorem. These texts are testament to the fact that mathematics was not just a theoretical pursuit in ancient India, but was intricately woven into the fabric of life. The seeds of mathematical brilliance were sown early in India, leading to a rich tradition of mathematical thought and innovation. As we move forward in time, we'll see how this tradition blossomed, giving rise to some of the greatest mathematical minds the world has ever seen. Stay tuned as we continue our journey into the fascinating world of Indian mathematics. From the inception of mathematical thought, we take a leap into the classical period, the Gilded Age of Indian mathematics. This era, extending from approximately 400 CE to 1200 CE, was illuminated by the remarkable work of several genius minds: Aryabhata, Brahmagupta, Bhaskara II, and Varahamihira, to name a few. Each of these scholars significantly advanced the field of mathematics in ways that still echo in the present day. Aryabhata, for example, is renowned for his work on the decimal number system and for introducing the concept of zero as a number. This was an innovative concept that dramatically altered the methodology of performing calculations. Aryabhata also made significant contributions to the approximation of pi, a fundamental constant in mathematics. He proposed that the approximate value of pi is 62,832 20,000ths, which is approximately 3.1416, remarkably close to the actual value. Following Aryabhata, Brahmagupta expanded on his groundbreaking work, leading the way in the use of negative numbers and establishing rules for arithmetic operations involving zero. Meanwhile, Bhaskara II is held in high esteem for his noteworthy contributions to algebra and trigonometry. His work formed the basis for many contemporary mathematical concepts and theories in these fields. Not to forget, Varahamihira's contributions to trigonometry, particularly his work on Sine tables, have secured him a distinguished position in the chronicles of mathematical history. Before these luminaries, however, stood Baudhayana, who is credited with the early statement of the Pythagorean theorem, often referred to as Baudhayana's theorem. It asserts that the square of the hypotenuse of a right-angled triangle is equal to the sum of the squares of the other two sides. Together, these pioneers developed an advanced mathematical system that was far ahead of its time. Their groundbreaking work on the decimal number system, zero, negative numbers, arithmetic, algebra, trigonometry, and the approximation of pi was revolutionary. They questioned accepted beliefs, created new paths, and expanded the frontiers of mathematical knowledge. Their contributions were not merely revolutionary, they were transformative, paving the way for future advancements in this field. These luminaries provided the foundation for many mathematical concepts we consider standard today. Their legacy persists in the mathematical principles and theories that continue to influence our comprehension of the world. As we journey through time, the Indian subcontinent steadily maintained its reputation as a hotbed of mathematical innovation. The 15th century heralded the rise of the Kerala school, making significant strides in the realm of mathematics. A remarkable achievement was their development of series expansions for trigonometric functions. The famed Madhava-Leibniz series, P4 equals sine 1, 1 3 plus 1 5, 1 7 plus 1 9, 1 11 plus, an achievement that remarkably predates the invention of calculus in Europe. This was a monumental breakthrough that has significantly shaped the way we understand and apply mathematics today. As we transition from the past to the present, let's not forget that the legacy of Indian mathematics is still very much alive. Enter Srinivasa Ramanujan, a self-taught mathematician whose novel work in number theory, continued fractions, and infinite series introduced the world to Ramanujan's summation theorem, utilized in the study of divergent series. The theorem proposes that the sum of all natural numbers 1 plus 3 plus 4 plus is equal to 1/12, a notion that, while counterintuitive, has profound implications in theoretical physics and string theory. Then we have Prasanta Chandra Mahalanobis, the pioneering mind behind the Mahalanobis distance, a statistical measure that's widely used in data analysis. C.R. Rao is another notable figure whose substantial contributions to the theory of statistical inference continue to influence statistics. R.C. Bose, with his significant work in design theory and the theory of error-correcting codes, is indispensable in modern computing and information technology. K.R. Parthasarathi has left his mark in the field of probability theory, and let's not forget Shizuo Kakutani, whose fixed-point theorem stating that every continuous function from a compact convex set to itself has a fixed point has profound implications in game theory and economics. Among these great names is Ashutosh Mukherjee, a mathematician and educationist who played a critical role in the progress of higher education in India. His dedication has inspired countless students to pursue mathematics. Thus, from the concept of zero to the intricacies of calculus, including the Madhava-Leibniz series, Kakutani's fixed-point theorem, and Ramanujan's summation theorem, Indian mathematicians have left an indelible mark on the world of mathematics. In the last few minutes, we've taken a whirlwind tour of Indian mathematics. We've journeyed from its roots in the Indus Valley civilization through the era of classical scholars like Aryabhata and Brahmagupta, who laid the groundwork for algebra and trigonometry. We've seen the strides of the Kerala school, pushing the boundaries of mathematical understanding centuries before Europe discovered calculus. Modern mathematicians continue to make their mark, building on this rich heritage. These contributions have been instrumental in shaping global mathematics. Next time you use a zero or calculate a decimal, remember the rich history and the brilliant minds that have shaped the mathematics we use today.